Hello and welcome to LRB Math Notebook. Today's lesson is on rational exponents. Rational exponents is a topic that my classes seem to have a difficult time grasping. So we are going to look at four types of problems that cover just about everything you will see in Math 1 with rational exponents. To start with, we're going to take x to the 1/4 power. When you have a fraction as an exponent, there are two things you need to remember with your fraction. The numerator becomes your exponent, and your denominator becomes the root. So, in the case of this problem, 1 will be our exponent, and we will have it to the 4th root. So, when you take your x to the 1/4, it becomes the 4th root of x. For our next problem, we're going to further apply that to what we are doing. We're going to have 81 x to the 4th in parentheses to the half power, and then all of that to the half power. We're going to do this problem in pieces. We're going to use the inside parentheses first and then work to the outside. So when we use that half power there, we're going to have 81 to the half power times x to the 4th times 1/2 power. When you take the exponent of an exponent, you are multiplying your exponents. That's how we get the 4 times half power. Now we are taking, as we said before, with the half power, the square root of 81. Square root of 81 is 9. And when we multiply our exponents with the variable, we just get x squared. And we still have a half power outside of parentheses to further work with. Again, we'll distribute into the parentheses, get 9 to the half times x to the 2nd times half power. Again, we follow our exponent rules, and the square root of 9 is 3. X to the 2nd times half becomes 1. So our final answer would be 3x. Now, let's look at numbers. In this problem, we have the square root of 75. 75 is not a perfect square. So we will need to break this down in order to simplify this expression. To start with, we take 75. We need to come up with what numbers we can multiply together to equal 75. Well, personally, whenever I think of 75, the first thing I think of is 3/4. So we're going to use 25 times 3. We're looking for the prime factorization, so we need to keep breaking down these numbers until they can't be broken down any further. The 3 is already a prime factor, so it stays as is. However, the 25 can be further broken down into 5 times 5. Once we reach this point, we can't go any further with the prime factorization. So now, since we're taking the square root, or second root, we need to find a pair of numbers. In this case, we have two 5s. Since the 5s are a pair, one of them is able to come out from underneath the root sign. The 3 is stuck on the inside. So our final answer would be 5 times the square root of 3. Now let's apply everything to this problem. 54 times x to the 9th times y to the 7th times z to the -3rd. And all of that is taken to the 1/3 power. Like we just did in the problem before, we're going to take the 54 and break it down. I broke down 54 into 9 times 6, and then those we further broke down, so we had 3 times 3 times 3 times 2 as our prime factorization. In this case, we're taking the 1/3 power, or we're taking the cube root. In order to do that, we need to have 3 of a kind, and one of those 3 is able to factor out. In this case, we have 3 3s. So that means our 54 becomes 3 times the cube root of 2. Now we need to work with our variables. So, like we did before, we will distribute the 1/3 to each variable. We'll have x to the 9th times 1/3 power, y to the 7th times 1/3 power, and z to the negative 3 times 1/3 power. As we multiply, we're looking to get whole numbers or a remainder of a fraction. So for the x, we get x to the third. Y to this, when we take 7 times 1/3, we have 2 with a remainder of 1/3. So we're going to keep those as separate exponents because this will make it the next step a bit easier. And then z, we have to the negative 1. Now our next step when we put everything together, the reason we kept the y's separate is because we'll have y squared, but then we'll also have the third root or the cube root of y. And as you can see here, we have the 3 from before with the 54 times x to the third times y squared, which is the sometimes simpler part. And then we have to take the cube root of the remainders, what was left under the root sign from before, the 2, and the 1/3 y. And then since z was to the negative exponent, or to the negative 1, we put it as the denominator. So our final answer, we have 3 times x cubed times y squared times the cube root of 2y over z. Hopefully this has been at least somewhat helpful for you and can show you the different ways that these problems work.